Hi everyone, today we are discussing characteristics of linear functions. So our first characteristic is domain and range. Domain are the valid x values for our graph and the range are the valid y values. So here on the first example, you can see that we have a blue line graph and we want to determine the x values of the domain. Remember that this line will go on forever, so it really doesn't stop at the end of our diagram. Our domain values are all x values here, okay? These x values are represented because this line will keep going forever in the bottom and the top. Therefore, it will eventually fill the entire graph. And we can say all x values by writing this in terms of infinity. When we look at an x-axis, the smallest amount is negative infinity, the largest amount is positive infinity. We have the same for the y-axis. The largest amount is positive infinity and the smallest amount is negative infinity. So here we could say that the domain is from negative infinity to positive infinity, and you want to make sure you have your negative and positives, and you always write it from smallest to largest. Okay. If we look at our second example, you can see on the blue line here that now we are talking about not a line that goes on forever, but because it has circles here, that this line actually stops. So our x values here only exist from this portion on the green at -3 all the way to +3. So our domain here is -3 to +3. And notice that they wrote it with the x in the middle, or sometimes they'll just put a comma so that you see the range from lowest to highest. Range is the y values. So back on our first example, that's how tall this graph is. Remember we said it's going to go on forever. So if I'm looking at the y-axis, the lowest value is negative infinity and the highest value is positive infinity. So our range would be from negative infinity to positive infinity. And the infinity symbol is really just a sideways 8. On our second graph though, if we look at our y's, they go from -2 all the way to +4. So we could write it with y in the middle, or we could just say -2, 4, meaning that is the actual range. So let's try a couple. So in this first one, we see that we have a domain and range, and this line goes on forever. Since it's never going to stop, our domain is negative infinity to positive infinity, and the range is also negative infinity to positive infinity. In the second one, this is also a line that continues forever because it does not have any dots. So here we can see once again our domain, negative infinity to positive infinity, range negative infinity to positive infinity. On the bottom left, now we see that we have circles. So this is going to stop. So I need to look at my x-axis and determine where this line goes. So from this highest point, I'm going to come down and mark, and that is at -3. So we are from -3, and then I'm coming over on my x-axis, and where does this dot line up on the x-axis? And it lines up at 8. So from -3 to 8 are the valid x values for this graph. Now, when I look at range, we're looking at y values. So I want from this location on the y-axis which is the 6, and this is the -5. So we're just bringing it down to the y-axis instead of the x-axis. So it's from -5 to 6. Okay, same thing can be done here. I would like to know my domain, which are my x values. So that's from -5. We're going to drop it to the x-axis. Drop to the x-axis, that's 4. So -5 to 4. And then our range is on the y-axis, so we're going to drop each point to the y-axis. So my lowest was -2, and my highest up here was 3. Okay, so my next topic is x and y intercepts. Now we've already talked about the x and y intercepts before. We said the x-intercept is where it crosses the x-axis, y-intercept where it crosses the y-axis, and we know that they can be written as ordered pairs. Okay. We also can determine the x and y intercepts just by following the formulas. So to find the x-intercept, I let y equal 0 and solve for x, and to find the y-intercept, I let x equal 0 and solve for y. Okay, so this is just a matter of solving the equations. So let's try them. So here, given the graph, we'd like to find the x-intercept and the y-intercept and write each as an ordered pair. So when I looked on the x-axis, I noticed that it crosses right here at 6. So my x-intercept is at the ordered pair 6, 0, okay, because it has an x value. And then my y-intercept, where it crosses the y-axis, is right here at 3. So my y-intercept is at 0, 3. Okay. All right. The next item says to find the x and the y-intercepts of this equation. All right. You're used to solving for y, but remember, this time we do not want to do that. We need to, excuse me, okay, we need to find the x-intercepts. So we're going to leave the equation the way it is. So to find the x-intercept, we're going to set y equal to 0. So we have 2x minus 3y equals 12. If I set y to 0, then that means that this entire piece will be 0, because 0 times anything is 0. So 2x is equal to 12. And when I divide by 2, x is equal to 6. Okay, so my x-intercept is 6. If I find the y-intercept, that means that the x is going to be set to 0. So once again, I'm going to write down my equation. 2 times 0 minus 3y is equal to 12. So this entire front part goes to 0 because 2 times 0 is 0. So we have -3y is equal to 12. And when I divide by -3, we have y is equal to a -4. So if I wrote those as ordered pairs, for my y-intercept, it would be 0, -4. And then for my x-intercept, it would be 6, 0. All right, so our next topic is increasing and decreasing. And these are also working with our x values. So we want to work from left to right, and we're doing x values only. All we're really looking at is slope. If I have a positive slope, then that means that it increases. From left to right, it's going up. It increases, it's positive. If it goes downward or has a negative slope, it decreases. If the slope is 0, then that means it's constant, it doesn't change at all. Okay, now, because this is increasing, then it increases on the interval of negative infinity comma positive infinity. Just like domain and range, it will increase for the whole picture. So here, we're not just concerned about does it increase, but where does it increase? When it decreases, once again, it's for the entire picture. It's for the entire line. So it's negative infinity to positive infinity. And the same thing for constant. But when we look at this picture here on the left, we notice that things change. We have some pieces here. It's not just one straight line, it's multiple straight lines, and we need to deal with each piece separately. So when we look for the increase here, okay, when we look for the increase, then we are looking for where does this line have a positive slope? Okay, so it is increasing in this section going up. The one that is flat is constant, and the one that goes down is decreasing. So sometimes just by marking up your picture, it helps. So where does it increase? Okay, these are lines. There are no points here. So we are still working with our infinities. So on the x-axis, it goes as far left as you can go, and it stops right here at -1. So it increases between these two green sections, negative infinity, and I'm sorry, this should be -1 here. Okay. Then where does it decrease? Well, it starts the decrease. We're going to drop it to the x-axis here at 3, and it goes all the way to the end of the x-axis. So it decreases between these two sections of green pieces, which is from 3 to positive infinity. And then where is it constant? It's constant between these middle two green sections, between -1 and +3 here. So you're working with sections on the x-axis that contain the increase, constant, and decrease. Okay, so you can try these two, but we'll work them together. Okay, this is a line. So this is going to increase, okay? This is increasing. The entire line is increasing. So the entire line, negative infinity to positive infinity. It decreases nowhere. So none. There are no sections of decrease. And there are no sections of constant. There are no flat sections. This line only increases. If we go to the second one, we see that we have a decrease section that's a negative slope and an increase section that's a positive slope. Okay, once again, these are lines, they go on forever. So I am increasing from -1, which is where they come together, all the way over to the edge. So from -1 to positive infinity is the increase sections between those two sections. It decreases from as far left to the -1, so from negative infinity to -1, and there are no constant sections. So remember, when you're dealing with your increasing and decreasing and constant, you want to drop everything to the x-axis and then write those ranges. All right, our last characteristic is end behavior. What is happening to the ends of the lines? Well, we know we get a straight line, so it's either going to be positive, like this one here at the top. They didn't write the middle of the line, they want you to look at the ends, or it's going to be negative. Okay, and they'll talk about things falling to the left and rising to the right. They want to know what is going on with that end section. So notice that they use infinities here. As x approaches negative infinity, so that means as I take and I go negative infinity, where is the graph going? Where's the end? Notice that up here on this first one, it's pointing down. So that means it's pointing to the negative infinities down here. It's going down. And then as I started from the center and I approached the positive infinities, what happened? The graph started going up again. So the y's approached positive infinity. This is what we're talking about, the ends. Okay, so I would know that if I look at a line and it's a positive slope. This is positive slope here. Okay, the line is increasing. Okay, when you have a decreasing line or negative slope, okay, it rises on the left and it falls on the right. So our first as section says as x approaches negative infinity, you can see that that line is going up to positive infinity. And you can see as x approaches positive infinity, the line is going down, so y approaches negative infinity. Y just means what is your graph doing? Okay, so that would be as if I looked at a negative slope line such as y equals negative 7x plus 5. Okay, so let's see if we can describe the end behavior up here for each of these questions. All right, now I look at number 1, y equals 1/2 x minus 3, and this is a positive slope. So we know that means that it's increasing. Okay. And I could even sketch what that looks like. I would know that this looks like a line doing this. Okay, that matches this top section. So as x approaches negative infinity, y approaches negative infinity. This is what we're talking about by describing. As x approaches positive infinity, y approaches positive infinity. Okay. All right, then we can do the second one. And it says here we know that we have a negative slope. Meaning that we have decreasing. Okay, I can draw a picture if I want. That matches the bottom. So when I describe end behavior, it's what's in this box. As x approaches negative infinity, y approaches positive infinity. As x approaches positive infinity, y approaches negative infinity. Okay, so the infinities mean which direction is it headed. Okay, so here we have two graphs and they want you to watch the wording. Okay, describe the end behavior for each by completing the statement. So they're going to get you started. All you have to do is write the end section in here. Okay, so down here, this says as x approaches negative infinity. So as I go to the left, What is the graph doing? As I go into this left section, the graph is actually going up. So y is approaching positive infinity. And you can even put the positive there. Okay, as x approaches the right, the positive numbers, what's happening to the graph? It's actually going down in this section. So y is going down to negative infinity. Okay, we can come over here to this one on the right. As x approaches the positive infinity, so this time they're starting off going to the right, what's happening to my graph? It's going up, so positive infinity. And the second part, as x approaches negative infinity, meaning I'm going to the left, this graph is going down, so it is going towards negative infinity. You must watch your wording. Okay, there are all the characteristics of a linear function.